Hello everybody, welcome from my side. My name is Michael Wiendl and today I want to show you how to work with pallets on the TNC 640 and also on HEIDENHAIN controls. At first I want to start with a short presentation, and after this we switch to programming station and make some programs with Pallet programming. So what can we do with the Pallet programming? At first we can link simple individual programs. So you see here I have on the left side workpiece 1 and workpiece 2 on the right side. And these workpieces I can link together with a pallet machining. So I do not need a pallet changer. I can also use a pallet file for programming on a machine without a pallet changer. I can also do tool-orientated machining. So if I have a multi-clamping system with a lot of workpieces, the same workpieces on it, then I can use the tool-orientated machining to save tool changes. Of course, I can use the pallet programming for a pallet changer so that the control and the machine gets the information I want to bring in the next pallet. And on this pallet there should be this NC program and this preset. I can also use the pallet machining together with a clamping tower. So I have a lot of different workpieces on a clamping tower, and I can use the pallet machining to program this clamping tower. So what are the advantages of pallet machining? I can save time because of tool-orientated machining. I can also get a really long runtime from the machines, because with a pallet changer, for example, I can machine 10 workpieces after every in one row. So the machine is running longer without man at the machine who need to change the workpieces. So how can we program these pallets? So at first we create the normal NC program, and this program we then combine together with the pallet file, and after the pallet file creation I edit the pallet file to bring in the NC programs, the presets and everything else. So the NC programs could be the normal NC programs, so with M30 at the end, and so a normal NC program what we are using normally for our machining. So when you want to work with pallets the first time, the machine tool builder needs to do a little bit preparation. At most of the machines this preparation is already done, so you can start directly with pallet programming. It's very important that you have the prototype for pallet programming in the PLC proto table, and there must be the extension .p. So prototype.p, that must be the extension, and this is the prototype for all the pallet files during programming. You can also change the columns what you want to see. So for example, if you get a software update and you have now the tool-orientated machining available, then you can go to the pallet file, then you type in the key number 555343, and then you can go to soft key more functions and edit format, and then you just click on, for example, pallet preset and click remove. Then this column is visible on the control, and this you can do with every column you want to see here. So this editor shows always all the available columns with this software version. So what do we have inside of a table? We have the number. This is just the number of the line. Then we have the type. Type is the type of what is the line? Is this a pallet? Is this a fixture, or is this NC program? So normally, if you have a pallet changer, we always have pallet and NC program, pallet program, pallet program. So the fixture, we come to it later, what we can do with this fixture here. The name, here we type in the pallet number or the path to the NC program. If we want, we can also add a datum table. So this is not the preset table, this is the datum table for every NC program, that we have a special datum table for every NC program. Then the preset, so the active datum, what we want to have. The location, this is new instead of TNC 530. So with the location, we can say this pallet is in the machine, or this pallet is not in the machine. So if you have a pallet changer, but the pallet is not in the machine, then you can mark this pallet with no end, that is, this is not in the machine, and you can bring it inside manually, for example. And we can also lock a pallet. So if the pallet is locked, then it will not be machined in the machine. So at first we always have the pallet, then we have the fixture. So fixture was used in ITNC 530 to change on a clamping tower, for example, from one side to the other side. On the TNC 640 and also TNC 620, this is not necessary, because there we have a 3D basic rotation. So we can define the sides of the clamping tower with the 3D basic rotation in the preset table. And the next thing, we have the program. There we put in the NC program. So we can use program and program, pallet and program. Then for tool orientated machining with a, for example, two-side clamping device, we can use the 3D basic rotation together with the program. And for the clamping tower, also the 3D basic rotation together with the program. So the preset stable instead of fix. So at 530, we often need the fix to change from one side of the clamping tower to the next. On the TNC 640, we have the 3D basic rotation. So you see here, I just added in the kinematic 2 workpieces. So the workpieces are in the preset table, line number 10 and 11. And you see in the line number 10, there we have the X, Y, and Z coordinate. And we have the SPC, SPB, and SPA spatial angles. And this is the 3D basic rotation. And you see the line number 10 has an SPA of plus 29. And the line number 11 has an SPC 180 and SPA plus 29. And these are my 2 workpieces, preset 10 and preset 11. And with this 3D basic rotation, we can easily fix this clamping situation. So we can use a 5-axis program with spatial angles, and every spatial angle is calculated later with the 3D basic rotation. So it's really easy to work with such a clamping situation on the 640 and 620. So a little bit configuration. So the machine tool builder can add a lot of macros. So for example, the pallet macro, the fix macro. So these are, the pallet macro is called when you have an entry in the pallet file of PAL for pallet. Then the control is just calling the pallet macro, and this is an NC macro, for example, to change the pallet to the next pallet here. The fix macro, the same. If you have the entry fix inside, then the control calls the fix macro to change the situation here. And we have also the prologue, epilogue macros. So this is for the ANSI program, what you want to do before the ANSI program and after the ANSI program. For example, go to a safe position. That you can do before and after every macro. For tool-orientated machining, we also need a tool call macro, and we need a special OEM pallet tool mode macro. This is for tool-orientated machining. The entries here are very simple. It's just an M146 and a tool call. M146 saves the current geometry information in a temporary file, and we get a special entry in the pallet table. And this is necessary for tool-orientated machining. So if you want to do tool-orientated machining, it's available since software 8 from the TNC 640, then you need this tool mode macro. Okay. Now we switch to the programming station and just make some examples with the pallet machining. So at first we want to create a new pallet file. So we type in pallet.p. The extension is important. .p says, okay, I want to have a pallet file. So the control opens a pallet file, and we have here the columns inside. Next step, I go to append and lines. And I can say, for example, okay, I want to have 6 lines. So, and here you see now the first column is type. So I have a pallet changer. So I want to say, okay, bring in the pallet number 1. And on this pallet, I want to do the program. With enter, I can choose the program what I want to have. For example, here, the program number 1. A datum. I don't want I don't want to use the datum table here. I want to use the preset. So preset should be number 1. The location is for the ANSI program not important, but the location is important for the pallet. So here I can say the pallet is in the machine. Otherwise the control will not use this pallet. When we normally don't use the datum table, I can also hide and sort columns. And I can say here, okay, I don't want to see the datum table. Okay, then the table gets a little bit smaller and easier to get an overview here. So next step, I want to have another pallet, number 2, and also at the machine. On this pallet, I want to have the program. Program should be ANSI program pallet and number 2. And preset number 2 here. And the same here, pallet, program, ANSI proc, pallet, and number 3. Okay, and on preset number 3 here. And this pallet is also available at the machine. So this is a simple example for a pallet changer. So bring in pallet number 1. On this pallet, I want to have program number 1. Bring in pallet number 2, program 2, and 3. So I can just link every pallet with an ANSI program. Also, I can link it with 2 or 3 ANSI programs. Okay, so when I have this pallet file, I can now go to program run. And in program run, I just open my pallet. So, and in the program run, we see now the pallet file. Under the pallet file, we will see later the ANSI program. And on the right side, we have the kinematic view. So now I can press ANSI start and the machining will begin. So at first, the first program with the preset number 1. And we do the machining here with the first program. Next step, new pallet, activate preset number 2 and make the machining. So I just link every pallet with one ANSI program. So I also do not need the pallet inside. I can also make a pallet program only with ANSI programs. If you have a lot of ANSI programs and you want to link it together, then you can also use the pallet file. For a real pallet changer, it is necessary that you have the pallet entry, because then the PLC gets the information, okay, now I need to change the pallets. When the pallet file is active in program run, I get the soft key edit pallet. So if the pallet is active in program run, I cannot edit or change anything in program editing here. So you see the same pallet is active, but I cannot do any changes. So this file is locked because the only possible thing to do it is now in program run, because the pallet file is active in program run, so I can only do an edit here. So I can say edit on, and then I can change here the pallets, for example, the presets here. I can also, when I want to get an information what is inside of the ANSI program, I can go to the ANSI program and I get the soft key open the program, and then I get the program here, for example, to do a block scan to a special point. Then I can go to the pallet line where I want to start, and then I can make a block scan inside here. If I want to come back to the pallet file, I just press the soft key and program, come back to pallet, and then I can do it. Also the block scan, I can say, okay, I want to do block scan to the sentence number 3 of the pallet number 3, and then the control is doing the machining here. So the line number I need to add here, so I want to have the line number 3 of the pallet 4. Then I can do the machining here, the block scan also. So that is just for a simple pallet changer. The next example, what we want to do is for saving machine time, and for this I just prepared the 3-axis kinematic. Just need to get out of the collision. So we have here a prepared situation, 4 workpieces. All workpieces are the same, and every workpiece has the same ANSI program. The ANSI program is looking like this. It's the program number 4. Oh, it's program number 5 here. Just a simple program with 4 drillings with a thread inside. So we can also make the quality higher of the NC test, and then we see this is the workpiece what we want to do. So we have 4 positions and we have 3 tools for every workpiece. And this workpiece I want to do now with tool-orientated machining. For this I have the Pallet file inside. So inside of the Pallet file you can see the first line is Pallet. Also, when I don't have a pallet changer in the machine, the first entry Pallet is very important because all the programs later on the pallet are under this Pallet entry. And we will see later during tool-orientated machining I have the workpiece status. And when it's after machining, when all is ended, every entry under the pallet will be just use the same workpiece status as the pallet on the first side here. So I can make it easily blank with one entry here. So the first line is Pallet and the pallet is in the machine. Then I have 4 entries of the NC programs. So the same entries and the preset number 1, 2, 3 and 4. So the important thing is now the workpiece status. It's blank. If it's blank, we can machine it. So you see here we have the possibility blank, incomplete. Incomplete is when the workpiece is started but not finished. Ended, this workpiece is complete, machined. Empty and skip. So empty and skip says we don't want to machine this workpiece. So you can react in a different way if it's empty or skip. So empty says there is no workpiece in the clamping, and skip this says there is a workpiece in the clamping, so we need to use the safe position. So normally we have blank or empty or skip if we don't want to machine it. And also very important is the method. You see TO is tool orientated. CTO is tool orientated combined with the workpiece over it. So you see all the 4 lines are linked tool orientated together. And the last line is WPO, so workpiece orientated. So I want to machine the first 4 workpieces tool orientated, and the last one, this is the TNC save, the reset program, the save position. This should be workpiece orientated. So the result we can see here. So we start with the machining. So control calculates all the program and now starts with the tool orientated machining. So first tool will machine all the 4 workpieces. Next step, we bring in the next tool. And now we are doing the drillings. Again, 1 tool change for all the 4 workpieces. And this will save time. And we get a quicker machining. So the pallet programming is not only for machines with pallet changer. We can also use it on a simple 3-axis machine when we put a lot of different or same workpieces on the table, just to save tool changes. And the last step is now the thread. So we can also link different programs. So it must not be the same program, it could be also a different program. The important thing is that we have nearly the same row of the used tools, that the control can combine the programs very easily. So for this, the easiest way is to do it with the same program, because there we have the same sequence of the tool, but we can also do it with different NC programs. And the last one is the label save. So now the tool is at the save position and all the 4 workpieces are machined. So when I now watch at the pallet, edit pallet, and I say edit on, we can see now that all the workpieces are ended. If the entry ended is inside of the workpieces, this workpieces will not machine again. So I need to change it back again to blank. And now I can machine it again. So it's always, we need to put in the new workpieces and we need to set the workpiece status to blank, and then we can go on with the machining. The next step would be the next program number 4. It looks like this. So we have 2 tilted surfaces. On the tilted surface we have our drilling. So simple 3+2 axis program, programmed with plane spatial, with spatial angles. And this we want to do now on our 5-axis machine. So kinematic, I change it to B hat C table, apply, okay. So, and here we have our clamping situation. So we have workpiece number 1 and the same workpiece on the other side here. So in the preset management, you see here the workpiece number 1, X, Y, and Z coordinate. And we also have here the SPA and SPC spatial angle. So this is the workpiece number 1 and the workpiece number 2 with the 2 spatial angles. And the presets, you see Y coordinate minus is the number 1 in the front and plus is the number 2 on the back side. So we link the programs together with the Pallet file. So you see I have again Pallet for the easy reset to blank. Then I have program number 4, and the TNC reset. Preset number 10, 11, and here we have the blank. And tool orientated and tool orientated combined with the 1 over it. If I don't use the CTO, if I use TO, then the workpieces are not linked together, so the machine will at first finish the complete line number 1 and then the complete line number 2, so the same if you have the workpiece orientated. So we always need the CTO for the second workpiece when we want to link it together. Okay, so on the machine it looks like this. The important thing is that after every tool call, also when you have an untilted machining, you need the plane spatial A0, B0, Z0 to be perpendicular on the workpiece. So I can just show it. So I activate the preset number 10. Preset 10 is activated. Now you see here the sign for 3D basic rotation. And now I just program tilt machining plane, plane spatial, A0, B0, C0, turn, Fmax, sequence plus, for example. And this is now the workpiece number 1. So you see the tool finds the workpiece number 1. The same with preset 11. I activate preset 11. I tilt. And I'm back again at the second workpiece. And this is the big advantage of the 3D basic rotation. So I just add the SPA, SPB and SPC angle in the preset table, and I can easily manage such a clamping device, for example a clamping pyramid or something like this, to get a good result here. Okay. So next step is now our program. So I start with the machining. So at first the tool call, calculation of the programs, and now we are doing the first tilted surface. So the angle was 29. So the control calculates the 29 with my programmed angle. And now you see the tilted machining of the two workpieces. Now we change to the other side and make the same machining on the second workpiece with the same tool, tool number 52. And also the second tilted surface. Okay. Change the tool, the drilling tool, and now do the drilling. Change the orientation. Okay. Change the preset, second workpiece, same machining. So this is a very good opportunity to get more workpieces with a 5-axis machining on the table, because normally we only could do one workpiece on this table, and with a clamping pyramid we can do 3, 4, it depends on the clamping how many workpieces we can do during one machining cycle. And this is a very good opportunity to save machining time. So, as you see before, when I want to have the pallet 3.p, so you see inside of this pallet we only have the column type, name, datum, preset, location and lock. So if I want to have all the possible columns, I can go to mode 555 343, and then I go to the third floor of the soft keys, more functions, edit format. And now we see all the possible columns which are available for my extension .p. For example, the pallet preset, I can say remove instead of datum. Normally I don't use the datum table because I always make the datum shift directly in the ANSI program, so I don't need this. Remove it. I want to see the workpiece status, the method and the CTID. The CTID is always saved by the M146. So this is a very important number or code for tool-orientated machining. The others, SP, these are safe positions. But I prefer the safe position in the NC program. So I always use a safe position with M91 regarding the reference system at the machine with the inside of the NC program. So I normally don't use the safe positions in the pallet machining. So store, okay, and here we have our complete table. And when I also know, okay, normally I make a tool-orientated machining, so I can prepare the table. So I can say insert 6 lines. So the first line should be pallet, and the other lines should be program. Okay, and also the pallet should be available for machining. Okay. The pallet preset we can use if you have a pallet changer and the pallets have a different mechanical difference from the set position, for example. Then you have one master pallet and the other pallets you can just add the difference. It's another preset table to use it here. The workpiece status is blank for all the workpieces. And the method should be TO and CTO on the other lines. So this could be a template for pallet for tool-orientated machining. And this template I want to add now to the control as the new prototype. So I go to the program management and I say copy to PLC, proto, and table. Copy it to PLC, proto, table. Okay. And when I now open the PLC, proto, and table, I can see here my pallet 3. And I see the prototype.p. So this is the file what the control opens when I type in the extension .p. So this I make a safe copy, so underline old. And now I use my pallet 3.p and I say copy prototype.p. Prototype.p. Okay. Yes, overwrite. And go on. So this is now my new prototype. You see, with all the lines inside. And now I can quick start with my machining. So the same as before, the machining number, program number 5. For example, pallet4.p. And now you see I am directly inside here. And I can now select the program, number 5, okay. I can also use now the copy field. And you can also use the Control C and Control V function. And preset 1, 2, 3, 4, 5. And then we have a very quick programming, and I don't need to do any changing in the NC program. So the NC program stays the same with M30 in it and everything. I only link everything together with the pallet file, and this I can use later for my machining. For example, last files, pallet 4. Okay, all the pallets are inside. So another interesting thing which is new with the software 8 from the TNC 640 is the batch process manager. So the batch process manager is an option. You find it if you press the Smart NC key. So right to the electronic hand wheel key, there you have the old Smart NC key, and with this key you can open the batch process manager. And if we watch now the batch process manager, we can open the active pallet, then we automatically open the pallet which is active in program run. So, and we see here, we have our program, and we see the tool number, or the tool with the name NC deburring diameter 10 is an external tool. So this tool is not available in tool changer. So this program will not run automatically. I need to make a manual intervention. So what is the batch process manager doing? I work with pallets, and the batch process manager automatically analyzes the ANSI programs. So are there any mistakes, any error messages during the ANSI program? The batch process manager also checks there is an active preset. So for example, for this line we have preset number 2. With this preset, is there enough driving range to do this program, or will there come any error messages regarding the limit switch? The batch process manager also checks if all the tools are available in the pocket table, and if the tools have enough cutting time to do this machining. So this is all automatically checked by the batch process manager, and I can also plan the night shift with the batch process manager, just to know, okay, will all the programs run through? For example, if I work also with sister tools, is there enough cutting time for every tool which I want to use? And when will all the machining processes stop? So that's also important, because when I see, okay, I want to run over the complete night shift, but the programs, when they are completely machined, stop at 5 o'clock in the morning, and then I can add another 1 hour program just to be sure that everything runs through. So for our pallet here, we need to bring in our NC deburring 10. So we go to the tool table and the pocket table, we say edit on, and then we just say here, which tool was this? That was the NC, that was the tool 172. So this must be inside of the preset table or of the pocket table. At the moment it's not inside, so I just added 172. Okay, then it's inside. And now I can make the same again. And now you see everything is okay. We have the feedback from the control. Now all the programs will run through and everything works fine. And that's the big advantage of the batch process manager. So I can also say edit on and insert the next pallet, insert after. I want to have a pallet. The pallet should be machinable. I want to insert after. I want to insert an NC program. So the NC program I want to use here, for example, program here. Okay, so now the control needs to calculate. I also add the reference point number 2. So now the control needs to calculate it. So in the background it will be all calculated through. And you see for this workpiece, I didn't insert my tools in the pocket table. So these are all external tools. So behind, in the background, in the test run, the control automatically creates a tool usage list. So the control works here with the tool usage file just to get all the informations of the tool, of the presets and everything. So for the first time it takes a little bit calculation because it needs some time to calculate the complete program through. So it's the same like we do an complete test run through the program. And this is done in the background, and so we can do it here directly. So we see now, okay, the first pallet will run through without any problem, and the second pallet is calculated at the moment. Give him some time. It depends on the program how long this calculation time takes us. So during this calculation, we can take a look at the possibilities during the pallet machining. So for example, when we want to do, when we interrupt the program, for example, so you see the pallet is inside, I push NC start, but nothing happens. Because added pallet, all workpieces are ended. When I say blank and NC start, then the machining starts again. So now I go on with the machining. And on the second workpiece, I just interrupt the machining because something happens with my miller and I want to interrupt the program at this position. So manual traverse, 3D rot is only the tool axis and I go away. Okay. Internal stop. Then I do some changings at the tool. So activate again, number 52. Okay. Also, I can make the reset. So plain reset stay and turn back. Okay. So now I go back to program run and I activate the block scan. And when I now say advanced on, I can select the last. Then the control automatically selects the last point where I left the program. And I can say NC start. And now everything is resetted again. Also the sequence to reset it, X, Y, and that, tilt the axis, okay, and now I can start the program again. And now I go on with machining at this workpiece and I continue with my machining here. On the second side and go on. So that's the possibility to do the block scan also during pallet machining. So when we now come back to our pallet number 4 and back to the batch process manager, we see now, okay, program will run 21 minutes, but I need to bring in the external tools, the mill diameter 32 and the mill diameter 8 I need to bring in, otherwise the machine will not continue the program and will stop during the machining. Okay, that was everything from my side. I hope I could show you a little bit more about the pallet machining. If you have questions, don't hesitate to contact me. You can use our email address. It's the 3103@heidenhain.de. So our service number, our service helpline, and there you can direct me if you have any question. So thank you very much. Bye bye and have a nice day.